Hi everyone, my name is Jessica Perez and today I'll be explaining Chapter 4, Problem 101 from the textbook. So the question states, replace the loading system acting on the beam by an equivalent resultant force in a couple moment at point O. So step 1 would be to identify our givens. So we're given that the length of the beam is 5 meters and the width is 0.2 meters. Then at force 1 it is 450 newtons and at force 2 it is 200 newtons. And the rotation is 200 newtons per meters. That then brings us to step 2, which is to determine what we need to find, and what we need to find is the equivalent resultant force and couple moment at point O. That then brings us to step 3, which is to make assumptions, and one must assume that the loading system acting on the beam by an equivalent resultant force are at 0. That then leads us to step 4, which is to make a plan. So step 1 would be one must find the sum of the resultant force for the x and y components. 2. Find the resultant force by taking the square root and squaring each term. 3. Find the theta of the angle. And 4. Find the sum of the moments at r and O. Step 5 would be to make a free body diagram. So I just reinstated what the picture said. The length is 5 meters, the width of the beam is 0.2 meters. At force 1 there is a 30-degree angle with a force of 450 newtons, and at F2 there is a upward force of 200 newtons, and the moment of rotation, or the rotation about the x-axis, is 200 newtons per meter. This would then lead to step 6, which is the solution step, and so to begin we find the sum of the components at x, which would be 450 times sine 30, which equals 225. Then you do the same for the y components, which would be 450 times cosine 30 minus 200, which equals 189.7, which rounds off to 190 newtons. Then you would solve for the magnitude, which would be the square root of 225 squared plus 189.7 squared, which equals 294 newtons. Then you would solve for the angle, which would be the inverse tangent of 189.7 over 225, which equals 40.1 degrees. Then to solve for the moment of rotation about O, you would do 450 times cosine 30 times the length, which is 1.5, subtracted by 450 times sine 30 times the width, which would be 0.2, subtracted by 200 times 3.5, which is again the length, at the force 2 plus 200 the rotation about x, and that would result us with 39.6 newtons per meters. And that is how you solve this problem. Thank you for following along and have a great day.